G'day, it's Prezzo here and welcome back to the shop. This is episode 4 of the re-engineering of the pull gear. And in this episode I'm hoping that we're going to get this thing assembled and we're going to see some wheels spinning and some oil flinging. So with regard to the lubrication on this, there seems to be two schools of thoughts coming in on the comments. Some people have said use oil, grease is better, olive oil lowers your cholesterol. Wait, what? You mean what? I shouldn't be cooking with this? I knew that fish tasted funny. I think I'm going to go with something like a chain bar oil that you'd use on a chainsaw, and the reason for that is that it's a very clingy oil. It tends to stick quite well. And the other thing to consider here is that when this thing is operating in its locked mode, that is when it's operating at normal 1-to-1 drive ratio, none of these components inside are spinning at all. So it just operates and spins as one whole unit. It's only when you drop it into the 4-to-1 ratio mode that these gears start to spin. And that's not all the time. So I'm thinking that I'm going to go with oil. The other problem with oil is that being thinner, it's going to tend to want to migrate out of the cavity in here and will fling out and end up inside the casing on the drill press. So I did think that I had mitigated that by having this lip and the recess on the ring gear, and then I was having a discussion with somebody about this through the comments, and it suddenly dawned on me that all you really need to do is have a shroud attached to the bottom casting section that covers that gap, and that way any oil that does make it through is going to drain back inside the cavity. Now, some people have said you could put a seal in here and fill this with oil and then use like a splash lubrication system. Once again, is it necessary? I'm not sure. I don't think it's sort of thing that's running 24 hours a day and running at high speeds or anything like that. I'll let you decide how you might want to do that if you're thinking about building one of these for yourself. Now, on that issue, I'm going to put the 2D drawings and the CAD model on, I think, Thingiverse. It's easy to get at that, and you can download that stuff fairly easily. I'm going to do it in two ways. I'm going to put up the design exactly as I've made it, without the mistakes, and I'm going to do a second version which incorporates this shroud attached to the bottom section of the pulley, and it will be drawn as a single piece of material. So if you're interested, you can get the drawings that way, and they'll be going up shortly. Now, let's move on and talk about this part. We have to now look at how this fits into the casing on the top of the drill press, or into the cover. So let's go over to the drill now and have a look. Okay, well here we are on top of the drill press, and this is the old step pulley that I'd used on this drill previously. And as you can see, there's a keyway cut right through the pulley from top to bottom. And that fits into this keyway, which is cut in the side of the motor shaft. Now, my problem is that the keyway doesn't go all the way through to the end of the shaft, and with the design of this spindle, the key is going to be inserted through this tapped hole in the side of the spindle. So it's essentially going to be like a square peg which protrudes into the bore, and obviously for that to work you've got to be able to slide that key down into the open end of the groove, which I don't have. So what do? It looks like we're going to have to machine out the groove all the way to the end of the spindle using some very highly technical and specialized machining technique. No, can't do that, sorry. The motor's going to have to come out. Okay, well let's move forward then. Let's see if we can get this key made and machine out the slot, and we'll see if we can get the spindle mated with the motor. So the stock for this motor key, or the spindle key, is just a standard 8mm socket head grub screw, and I've got that set up in a square collet block. Oh, you get the idea. God, how does click spring do that? there's the square end on our key. I'll just deburr this and try it in the slot. It's a little bit undersized, and you can see there's still a little bit of thread left at the corners there, so I wanted to make sure I got at least one good flat surface up against the load side of that key slot. Okay, so there's our key done, and there's our 8mm hole, and that's going to just simply protrude through onto the inside of the bore far enough to engage in the motor spindle keyway. So you probably can't see it, but it's sticking through there about 3mm, which is deep enough. So next step, you've got to operate on the motor spindle and extend the keyway right through to the end of the shaft, and then we can do a trial fit with this part. Well, you know what, the angle grinder would have been quicker and easier, but here we are, set up on the mill. So what I've got is the motor sitting on a piece of plywood just to bring it up to the convenient height that I can work at. And I had to get the slot centered between the two jaws. Now I'm sure there's lots of very special ways of doing that, but all I did was put a parallel onto the front of the vise, and I measured from the edge of the slot to the edge of the parallel, and I repeated that process at the back, and after about 3 or 4 attempts I got that within a couple of hundredths of a millimetre. So remember, all we're doing here is just providing access with the key from the end of the spindle, and the key is a little tiny bit undersized, so even if I get this, not perfect, I can dress it with a file and get it right. So what I need to do now is get the cutter centered on the slot, and let's go ahead and cut the slot. Alright, near enough for a sheep station, I guess. So here's our key, and it should slide into that slot. Okay, let's clean that up, get the motor back in the machine. Okay, well there's the key slot extended all the way through to the end of the motor spindle. The key now protrudes inside that bore by about 3mm, and it should, there it goes, just slide on like that. I'll put some thread lock in that later on just to make sure it doesn't sort of rattle at all, and the grub screw on the other side is going to provide the permanent locking. So I guess the next thing now is to start pressing stuff together, and I've sort of put this off long enough. I've been a bit hesitant to do this because once you start pressing bearings on, getting them off again means you often damage the bearings. So if anything goes wrong with the assembly, that's what I'm going to have to do. However, come on, can't put it off any longer. Okay, well there we are. We've got the shaft inserted, the two bearings pressed in top and bottom, and I can see the grub screw through that access hole, so that's good. The next step is to press on the spur gear or the sun gear, and the little key that I made, I beautifully rounded off both ends to fit that machine slot. I realized later that the rounded end protruded above that shoulder there, and that was going to interfere with the top section that's going to be pressed on. So I just filed that off square. The sun gear can now just simply slide on. And I was going to find some way of fixing that on there permanently, but I realised you don't need to. So I'm just going to tap this down. And that's a sort of a firm-ish fit. When I check the drawings, the bearing in this top cap here bears on that shoulder. So if all the clearances are correct, I don't need to worry about that sun gear sliding off. It can't. So I'm going to put this aside for now and turn my attention to the top cap. Somewhat fortuitously, in the mail just now I received the package which contains the little brass ball oilers. So there are 4 6mm oilers that fit these 4 holes here, and I've just checked and they look like they're going to be a light press fit. So let's just try one. So each one of these oilers has a little bit of a lead on it, so it's tapered on the end that will fit into the hole. I drilled these holes just under 6mm. I'm resting this on a piece of plywood so I don't damage any of the mechanism underneath here. So, let's see. Perfect. Nice. Okay, so this is now ready to go together, and just as a final lubrication, I'm just going to put some of this chainsaw bar lube on here. Still not really sure what's best here, but I think this stuff is sort of clingy enough that it's going to hang on. And like I said in the beginning of this video, the gears don't operate continuously. Okay, and I'm just going to put some on the spur gear. I'll put just a bit around the ring gear as well. So I'm really keen to see if somebody builds another version of this and incorporates some fancy sort of oil reservoir into it. Okay, so the final part now is to press these two halves together, and in theory it should be a light press fit. Now in practice I checked the diameter of the shaft with the bearing seats. It's about 1/100 of a millimeter undersized, so it may end up being just sort of more like a sliding fit. If that's the case, I'll dismantle it and I'll have to use Loctite or thread lock or something. The other really important issue here is that these planet gears have to mesh with the ring gear as it all goes together. Now if I just press it on without meshing those gears, I'm going to strip a tooth or damage something. So I'm going to do this off camera, and I've just realized that the actually the sun gear has to align as well. That's going to be fun. So okay. Alright, I think I'm just going to tap this together and just go very slowly. Alright, join me in a minute. Well, we're back and it did go together. It took a couple of attempts. I had to sort of lift it off and put it back on again and re-engage the gears, and it all started to go together. It did have to be pressed. I was sort of worried that it was just going to slide on there or drop on there, but it didn't. So that's all good. It's a little bit tight at the moment. I think this bronze bush at the top here is going to have to be run in a little bit. And I did put it on the drill press and run it, and there's a bit of backlash. You can hear that, but that's the backlash that I built into it. The little labyrinth seal has worked as I expected, and there's nothing touching there, so that's all good. So let's go and put it on the drill press and just give it a quick test run. Okay, well here we are with the pull gear on the motor. I've locked the pull gear to the motor shaft now with the single grub screw. I haven't overdone that because it's going to have to come off again. Now I've noticed that it's flinging a little bit of oil. There's some inside the cover, there's some back here on the wall, but most of that came from that plain bronze bush on the top. I flooded that with oil when I did the first assembly because it felt a little bit on the tight side. But all that oil is going to eventually dissipate. I've got the belt on and I've tensioned the belt. What we'll do first is just have a look at it running in its direct drive mode. Now I don't have the latch on top yet, but you'll get the idea. That's sped up to speed, and that's running more or less in direct drive mode. There's a little bit of vibration there, which is unfortunate. It's sort of the fit of the interior spindle on the motor shaft wasn't quite as good as I would have liked. It sort of just goes on a little bit rattly. Now the most important thing is that when you want to drop it into this low speed mode, this pin has to be inserted, and I'm going to have to come up with some sort of a bracket to support that so that it can be inserted and locked, or pulled out and locked. Now luckily there are 2 threaded holes in the drill press head which I can get at, just down here, and I can make up some sort of a fabricated bracket for now. Maybe later on I'll make a casting of some sort, but it doesn't have to be anything fancy. So let's just engage it now in the low speed mode. Now I've got the motor running at about half its RPM, so the variable frequency drive is set to about 25-30 Hertz. Wait till I just check that. 32 Hertz, it's a little bit over half its capacity or its full RPM range. Let's just have a look as we switch it on. And it's a little bit grindy, a little bit of gear noise there, but certainly nothing that you'd worry about. And I can see that the spindle at this end, you can't see it, but it's running, I'm guessing, at about 150 RPM. Let's just put that under a load. Right, certainly can't stop that with my hand, which I could do before. And I reckon that'd drive a 16mm drill bit no trouble at all. If I run it up to its full RPM, you can hear it's a little bit noisier, but not too bad. Now remember that I'm not going to use this all the time in that reduction speed mode. It's going to be running mostly at its full locked mode, or in its full locked mode. So you know, that little bit of gear noise is acceptable to get the extra low rev range that I want. Well, there's the latch fitted on top there now, and there's still a few unresolved problems with that I'm going to look at. The fit's a little bit on the tight side, and this little knob which lifts the latch up isn't actually attached to the latch itself. It's just sitting in a pocket there at the moment, and I thought that would be suitable, but it's not. So I'll probably need to Loctite or pin that at some point in the future. So with that, in that reduction speed mode, you can put the pin in there, and remember that the internal shaft is now free to rotate as the latch is held above the top of the pull gear. So if we start that up, you can see the latch rotating, and what you should be able to do then is align the slots, lift the latch and drop it in. You get the idea. Alright, here we are with the latch sort of semi-fitted. It's a little bit tighter than I would like it to be, and it's going to need a bit of fettling to get that right. But let's see it running in its direct drive mode. And as it slows down, you'll hear a little bit of rattling from the backlash in the gears. So I think that's more to do with the motor cogging a bit as it slows down. So that's okay. I've got 3-step pulleys at this end. I've got 4 at the other end, but I won't use the very top one. And of course I've got the infinitely variable frequency drive as well. So that's going to give me all the range of speeds that I will want for this. Now I'm going to leave this video here. In the next episode you're going to see the fully resolved design, I hope, with the detachable pin for the low speed drive. We're going to have a look at modifying that cover, and you're going to see a very happy user operating his drill press with dirty great big drill bits through difficult material. So for now, thanks for joining me, and I'll check you out in the next video.